Hi, hello. Today we shall be developing panel data using following three methods. And number one, pooled OLS model. Number two, fixed effect model, and random effect model. And here we have six computer companies such as 1, 2, 3, 4, 5, and 6, and we have three variables here such as cells of computer in volume, price of the computer, and repairs of the computer. And now we want to check the associationship between cells and other two explanatory variables such as price and repairs. Our data is from 2000 until 2010. So observation would be 66 in total. Okay, I can show you the data that we have for these six companies. Okay, first variable is sales, price, and repairs, company, and year. And here sales is the dependent variable, price and repairs are the independent variable, and company we have six company. Example, this is 111 is the company number 1, and the data from the year 2000 until 2010. So this is all 111 until here. Then company 2 begins. Company 2 is all 2. You can see from here until 2010. Then company 3 begins 3 3 3 3 3 3 until here 2010. Company 4 4 4 until here 2010. Company 5 begins from 2000 until 2010 as before. Company 6 starting from here and finish here 2010. So this is my data for 6 company and their sales volume, and then their prices of the product and the number of repairs they have done so far. Okay, now with this data we can develop a panel model. That is our plan, and we have three models. Number one is the pooled OLS regression model, and here we pool all 66 observations together and run the regression model, neglecting the cross section and time series nature of data. By combining 6 companies by pooling data, we deny the heterogeneity or individuality that may exist among 6 computer companies that we have. In other words, we assume that 6 companies are same under our pooled regression model. That means under this method all the companies are same. And now our second method, fixed effect model. The fixed effect model allows for heterogeneity or individuality among 6 computer companies by allowing to have its own intercept value, meaning that, in other words, 6 companies may not be same under fixed effect model. And finally, random effect model. What is this? Here our 6 companies have a common mean value for the intercept. And here what I'll do, I shall use R software to run panel data, and R software is available online, and this one is a free software indeed. So here the terms of uses, right? So you can see, right? Okay. Now we see our model. We develop our model using R software. So which one is a free software given online. Okay, so then, okay, so this is R software, you can see, right? So we have to write the program now. So we have to do it program here. So I start to write install.packages and PLM, panel, alright, panel data, so on, install packages. So that is the first command. Then press enter. After pressing enter, you have to select your area. So I select my area, then press OK. So it is going on in the system, downloading. Okay, after that I have done until here. Okay, after that I have to continue to write program library and PLM, that I have to write, enter. Okay, then I have to write my data, and this one read.csv by, and my file is located under C drive, economics folder, and the name of the file is the cell CSV. Actually this file is CSV file located in C drive, and so read CSV. Okay, make sure you have to write the command very clearly. If you are wrong, then the result will not come. So after typing we must double check. Okay, I think that this command is all right. Then I enter, then attach is my data that I write, then enter. Okay, then now I have to find out which one is the dependent variable and which one is the independent variable that I have to mention. Suppose y can represent the dependent variable, so I write it, and I have to write C bind, and our dependent variable is cells, so I write it, then enter X, then I do it again C bind, and we have two independent variable, one is repairs and price. I write it these two, then enter. Okay, now I shall estimate the first model, pulling OLS model. So my command is like that, pulling this one, then PLM, then X, then data, my data, then index C by first. Then we have one variable company, so we have to write it, and we have one more variable, that is year. Okay, then our model name is pooling, right? We have to mention it, pooling, then the bracket is closed, so I make it slightly big so that you can see better. Okay, so I double check one time, because if mistake, then I have to type again, right? I make it big slightly, just 1 minute. Okay, so pulling PLM, YX data, my data, index C, company, year, then model name is pulling. I think is setting is all right. Then I press enter, then I write summary and write pooling, right? Then I enter, the result will come up. You can see the summary pooling result way, right? And here balanced panel N66, that we have the total observation, and here you can see, and our here cells is the dependent variable that we know already, and repairs and the price are the independent variable. Okay, first I talk about the repairs. Here the estimate divided by standard error, I can get the p-value and the corresponding probability value. Okay, suppose 8.83 divided by 7.37 should be 1.1982 and corresponding probability value. Okay, now the question is that which variable is significant, repairs or price? Okay, I check one by one. First I talk about repairs. The probability value is 23.53%, which is more than 5%, meaning that repairs variable is not a significant variable to explain the dependent variable, which is cells. What about the second variable, price? Is it significant? Probability value is 0.9387, which is less than 5%. So when the probability is less than 5%, then it becomes significant. So price is a significant variable to explain the dependent variable, which is sales. And finally, I check the F statistics. P-value is significant because it is 2.1%. So meaning that our model is very much okay because p-value is significant. So this model actually is our pooling OLS model, and in this model we have assumed that all the 6 companies are same. Okay, then we shall make our second model, fixed effect model. So how to type the program? So I write fixed as before. I follow the almost same procedures that I did last time. Data, my data, then index equal C by company, then year, right? Then I finish the bracket. Model is equal to within, then I give it okay. I double check one more time. Fixed PLM wide axis data, my data, index C, company, year, model, within. Yes, I think it is all right. Then press enter, then write the summary, and here I write fixed. I write fixed here and enter. So as before, you can see this is a fixed effect model, and in this model we assume that 6 companies are not same, they can be different. Okay, and here you can see, and sales is the dependent variable. Okay, first I check this variable repairs. Is the repairs is a significant variable? Probability is 86.11%, meaning that repairs is not a significant variable. What about price? Yes, the price is a significant variable because the probability is less than 5%. So here also price is a significant variable, and if statistics is also significant, probability is 0.1176%, which is very low. So meaning that this model is all right because F statistics is significant. And the last model is the random effect model that we can make now as before. PLM, then Y by X, data, my data, then index by C, company by year, model is equal to within. Okay, random PLM, data, my data, index C, company, year, model. No, this time random, not within. Okay, last time it was within. We checked. Last time it was within, but this time it is random. We are developing a random model, right? So I think we are right. Let's done it. Then I press OK. Okay, then summary is the random that I do here and enter. So here is the entered summary random, right? And here the first variable repairs, the probability value is very high, 85.05%. so repairs is not a significant variable, but the price probability is very small, less than 5%. so here also price is a significant variable to explain sales. And finally, F statistics is also significant, so meaning that this model is also okay. All right. Okay, now we have developed three models. Out of three models, which model is most appropriate to explain the associationship between sales and repairs and price, right? Okay, so first I check between two model. They are a pooled OLS model and random effect model. Sorry. First I check between two model. One is fixed effect model and random effect model. That I do first. So here I'm doing it. Just 1 minute. Okay, just 1 minute. So just 1 minute. I'm setting the whole things. Okay. Come. I'm making it small, little bit. Okay. I make it small, little bit. Okay. It's all right. Okay, bring it up. Okay, little bit up, little bit small. Okay, fine. Okay, so first I check between fixed effect and random effect model, and here I take the Hossain test to check it, right? And our null hypothesis is, the null is, just 1 minute, I just double check. Null hypothesis means is that random effect model is appropriate, and alternative hypothesis is fixed effect model is appropriate, right? Okay, and now I put the command to estimate the Hossain test, PHTEST. So I write it fixed by random. I write it PHTEST, fixed and random. Then I press enter. So you can see Hossain test, chi-square value and corresponding probability. Probability is 99.42%, which is very high, meaning that we cannot reject null hypothesis, rather we accept null hypothesis, meaning that random effect model is the most appropriate. Okay, now I check between random effect and pooled OLS model, right? That I check that between these two, which one is the most appropriate, right? So here what is our null hypothesis? First I said the null hypothesis, pooled OLS model is appropriate, and alternative hypothesis is random effect model is appropriate, right? Okay, so we can check it using Bruce-Pagan test. So I write the command plm test, right, and I write pooling, then I write type equals C, BP, then this one and this one. Okay, this one is my command. I double check, yes, this one is a command, plm test pooling. Okay, I enter, yes, the result has come up, Bruce-Pagan test, chi-square value and corresponding probability. The probability value is very small, less than 5%, meaning that we can reject the null hypothesis and can accept the alternative hypothesis, right? Meaning that random effect model is appropriate. Okay, out of 3 models, we have seen that random effect model is the most appropriate. Okay, now I derive the random effect model again as before, random effect model as before. I just do it the way I did it before. I follow the same procedure as before. My data, oh sorry, I done a mistake. The command should be data equal my data, then index, then equal C, then company, then year, then comma, then model equal to random. Then I double check, random plm yx data, my data, index C, company year, model random. I think we set it properly. Then press enter, then summary random, right, then enter. So this is the random effect model, right, random effect, and this model is the best model out of 3 models. And here I can see the repairs is not a significant variable, but the price is a significant variable to explain the sales, our dependent variable, because probability is very small, less than 5%. Okay, but I think there is only one problem with the price. What is that problem? You see the coefficient here is positive, right? Coefficient is positive, meaning that when the price goes up, sales also goes up, and when the price goes down, sales also goes down. Actually, that does not follow economic theory, because normally when the price goes up, sales goes down, and when the price goes down, sales goes up. That is the theory, right? But here, so here the story is different. So I have doubt about this model. I have some doubt that whether we should accept this model or not. Okay, then I check, and if you ask me, I shall not accept this model because it is against the theory, against the natural phenomena. Okay, now I check finally whether this model has serial correlation or not. That we check, and I write the command as before, pcd test and fixed, then write test, then equals c and cd. Okay, pct test fixed test c. Okay, write properly, then I press enter. Oh, I have done a mistake. Okay, pcd, I think I have to type it again. Pcd test should be fixed, then test equal c by cd. Okay, then fill it up 1 2. Okay, double check again, fixed comma test c by this one cd is fine. Okay, so what is the problem with this one? I think no problem. Test c by cd second bracket. Okay, I have given everything properly. PC. Sorry, last time I give PCS, so actually this thing should be PCD. Okay, now it is all right. I press enter. So here is the Pesaran CD test for cross-sectional dependence, and here is the Z statistics and corresponding probability value. Okay, here our null hypothesis is that there is no serial correlation, right? That is the null hypothesis. And alternative is there is serial correlation. Okay, and here probability value is 33.75%, which is more than 5%, meaning that we cannot reject null hypothesis, meaning that we accept null hypothesis, meaning that there is no serial correlation in this model. Thank you very much for being with me for a while.